Okay, morning year 12, and today's lesson is titled Algebraic Division. Now, you did do this if you came to the session when you were in year 11 and you were you're interested in taking A-level maths. Different teachers taught you algebraic division. I'm just going to recap that because that was a long time ago and how we use that with partial fractions. So I'm going to look at this question here on page 16 of exercise 1F. So if you'd like to turn to that, this is the question. It has your fraction here, your algebraic fraction. You can see the degree of the top is 3 and the degree of the bottom is 2. So we have an improper fraction because the degree of the top is the same or more than the degree of the bottom. And it's asking you to put it in this format and find A, B, C and D. Now, there are two methods to do this. The method I'm going to show you is using algebraic division. You need to know how to do algebraic division anyway for other parts of the pure course. So I'm just going to reinforce that method today. So on a separate piece of paper, you are asked to, just put this here, you are asked to divide the numerator by the denominator. So let's just write this down here. So the numerator goes inside the division, okay, and the denominator goes outside. So the method that we do is we say, how many x squares go into 4x cubed? We take the highest power of x. How many x squares go into 4x cubed? Well, the answer is 4x. Now we multiply 4x with what's on the outside. So 4x times x squared is 4x cubed. You should get the same as the first term because they're going to now cancel when you take them away. 4x times 2x is 8x squared. And 4x times minus 1 is minus 4x. And what I do now, as you would with long division, is I'm going to subtract these two. So I get 0 here. Minus 5 minus 8 will give me negative 13. Minus 3 minus minus 4, so minus 3 add 4 will give me plus x. Sorry, the question has a plus here, not a minus. Okay, apologies for that. I'm just going to double check that now. On page 16, apologies for this. Just check I have written that down correctly. Yes, it is a plus, yeah. Okay, so plus 3 minus minus 4 gives me 7x. And take away the 14. So in the question, this was a plus, the actual original question. Okay, so what do I do now? I now say, how many x squared go into minus 13x squared? Well, the answer is negative 13. I now multiply negative 13 with everything on the outside. So negative 13 times x squared, negative 13x squared. Negative 13 times 2x, negative 26x. Negative 13 times minus 1, plus 13. I now subtract these two. So I get 0, 7 minus minus 26 will give me plus 33x. Negative 14 minus 13 will give me negative 27. So, what I have is when I divide, if I just bring back the other sheet of paper, when I divide the denominator into the numerator, the bit on the top is the number of whole times it will divide. And this here is my remainder. Now this here is called my quotient, the number of whole times it will divide, and this is my remainder. For example, if I was doing it with numbers, okay, so let me just do a quick example with numbers. I'll do that with a different colour. Say for example I was doing 17 divided by 4. Yeah, 17 goes inside, 4 goes on the outside. I say how many 4s go into 17? Goes 4 times. 4 times 4 is 16, and I take them away. So 4 is my quotient, my number of whole times, and 1, so this is my quotient, Q, this is my remainder, R. 1 is the remainder, and it's 1 quarter. Yeah, so 17 over 4 is 4 wholes and 1 quarter. So when we're looking at this question here, my division, when I'm dividing this into here, the number of whole times will be what's on the top of my division, plus my remainder. This remainder here will be 33x minus 27 divided by what I was originally dividing by. Yeah, so the remainder is this divided by what's outside. So looking at the numbers, my remainder is 1 quarter. Okay, so I want to really understand why we write it like this. Okay, so this is my quotient, this is my remainder. So now I've done the question. I've worked out what A is, what B is, and what C and D is. So I can see A is the number of x's. So A equals 4. B is negative 13. C is 33. And D is negative 27. Okay, so that's a revision that you did way back in year 11 of algebraic division. You might need to go through this video again. I'm going to do another example with you, so don't worry. But this method is key. Okay, so your go. This is question 9 from book. Sorry, apologies, the dots have come underneath. So, question 9. If I just find some spare paper. Yep, I've got some here, and we'll have a look at doing this question. So pause the video if you think you're confident. If you don't think you're confident, then just listen to me one more time and I'll go through this method. So this is question 9, exercise. In this case, it's a different exercise actually. This is exercise 1G, question 9. Okay, so what we are doing is we are dividing 8x cubed plus 1 by my denominator. So my numerator divided by my denominator. So what will go inside the division sign is 8x cubed plus 1. Now I've got no x squareds, I've got no x's, and I've got plus 1. Okay, now I'm going to write those there and you'll see why in a second. And I'm dividing by 4x squared minus 4x plus 1. Now you can see that this is an improper fraction. The degree of the top is 3, which is more than the degree of the bottom, which is 2. So we have a whole number of values of my denominator going into my numerator. Okay, so the method is 4x squared into 8x cubed will go 2x times. Okay, if you're not sure about that, just do a little division here. 8x cubed divided by 4x squared. 4 goes into 8 twice. Take away the powers. Okay, so 2x if you weren't sure about that method. Okay, now I'm going to multiply 2x with everything here. So 2x times 4x squared. 2x times minus 4 is minus 8x squared. And see, I've put it underneath the x squared. 2x times 1 is 2x. So it's important that I line up my x squares, my x cubes, my x's and any numbers. In this case, I haven't got any numbers. Now I subtract. So I'll have 0x cubed. 0 minus 8 will give me plus 8x squared. 0 minus 2 will give me minus 2x. 1 take away 0 will give me plus 1. So now I'm going to say how many x squareds will go into 8x squared. Well, I'll have exactly 2. So let's multiply this out. 2 times 4x squared is 8x squared. 2 lots of minus 4x is minus 8x. 2 lots of 1 is 2. Now let's subtract. Minus 2 minus 8 is minus 2. Add 8. This is where you may go wrong. 1 minus 2 is minus 1. Okay, I stop here. Okay, now the reason I stop here is because what I've got here, my remainder, the power, the degree is 1 and the degree is 2. So this can't divide into here a whole number of times. Okay, so let's put it now into the format that it's asked you for. So when I am dividing this by this, I will get my whole number, my quotient, which is on the top, that's my quotient, plus my remainder, and my remainder is divided what I was originally on my denominator. Okay, so that's my quotient, that's my remainder. Now let's compare that to what the question asks us to do. So the question asked us to do this, okay, to put it in the format ax plus b. Well, we've got the a, which is 2, we've got the b, which is 2, that's my quotient. Now it's changed this in using partial fractions, and it looks like we've got a repeated root here. So we're not quite ready to say what c and d are. So we're going to now use partial fractions to find out what c and d are. Okay, so let's try that bit. That's more paper needed. Okay, so I am going to look at putting this into partial fractions. Well, the first thing that I've got to do is factorise the denominator. Now I reckon it's going to be 2x and 2x. To get 1 and 1, I need my negatives. Okay, I'm just going to double check that to be absolutely certain. I mean, you could have used your AC method to go from here to here. I'm just going to double check it. 2x times 2x, 4x squared, minus 2x plus 1. Yep, that works. That's the same as what I want. Yep, so that's correct. So you can see here that I could write it like this. Okay, and I can see I've got a repeated root. So when I change this into partial fractions, I'll call it c, that's what it was in originally. I'll have a number, a constant over 2x minus 1, plus another number over the repeated. So remember we did that when we looked at repeated factors in partial fractions a couple of lessons ago. Okay, and now I go through all the business of finding C and D. So let's just recap that. So I'm going to put it over my denominator. Okay, so this will go into here times 2x minus 1 plus just D. So my numerator 6x minus 1 will equal C 2x minus 1 plus D. Okay, if I let x equal a half, that will make this disappear. So I'll have 3 minus 1 equals D. So D equals 2. And if I put x equals 0, okay, I'll have negative 1 on this side. I'll have negative C plus my D is 2. So C will equal 2 plus 1, which is 3. So if you go back to the original question now, I have got my answers for all my unknowns. This was the original question. So my A worked out to be going back to this part here. Yeah, my A is going to be 2. My B is going to be 2. And then I worked out C to be 3 and D to be 2. Okay, so now I've worked out that question. So that was algebraic division and repeated partial fractions. Okay, now it's your turn to try some of these at home. I would like you to go to, please, the mixed exercise, page 19. This is a mixed exercise 1, and I'd like you to try these 3 questions, please. Show all your method, and that is the end of chapter 1. Thank you for listening.